Lesson 5 is on graphs of functions and equations. So we've been talking about what a function is. For every input, there is exactly one output. But now we're going to be working on how we graph it and what can we tell from graphs. So at first here, it's pretty much like what we've been doing. We're going to start by writing that equation. So it says the distance Giselle can run is a function of the amount of time she spends running. She can run 3 miles in 21 minutes, and we're going to assume that's a constant rate. So it says write an equation in 2 variables that represents her distance run y as a function of time x. So again, y over x. Now we're going to set that up then for our proportion here. We're keeping in mind that distance is y and time is x. So this is in this case going to be miles, and this is minutes. So we run 3 miles and 21 minutes. And then remember, what we've been doing is using cross products. So we have 21 times y equals 3 times x. And then to solve for y, because we always solve for y, we divide both sides by 21. And we're going to get some kind of decimal. I'm going to choose just to kind of write this and leave this now as a fraction. 3 goes into itself 1 time, 3 goes into 21 7 times. So I'm just going to leave it right now as y equals 1/7 x. And again, y here, this is miles, and x is the minutes. Okay, so now we're going to use this equation here to determine how many miles Giselle can run in 14 minutes. So if it's 14 minutes, remember that's our x. So what we do is we're going to take this x and we're going to plug it in here. So I'm going to get y equals 1/7 times 14. You can write it as 14 over 1. Basically, we're taking 1/7 of 14. If you want to cross reduce, 7 goes into itself 1 time, 7 goes into 14 2 times, and you multiply all that and you basically get 2. 2 what? Y is miles. We can do the same thing now for part C here. But this time it's asking for 28 minutes, so x is 28. And we'll again plug that in here for the number of minutes. Y equals 1/7 times 28. I'll write it as 28 over 1. And then if you don't cross reduce, you can multiply straight across and get 28 over 7, which divides out to be 4 miles. Okay. And then I guess we can do the last one too. Basically the same thing. 7 minutes, so x equals 7. Y equals 1/7 of 7, which basically is just 1 hour. Okay, so you can see the value in having this equation. Sorry, there's a little glitch in the video there, so I don't know exactly where it left off. But what I'm saying is, if we do all this, we can see the value in this equation. We have one function, one equation, and we can figure out how many miles she's going to run from it. But now we're going to go back to focusing on these graphs. So we're going to take this information and we're going to put it on a graph. So, keeping in mind that it's not coincidence that we use x value or x and y's when we're figuring out this stuff, because when we want to graph things, remember, we have our x coordinate and our y coordinate. And as always, this is going to be the minutes in this case, and this is going to be the miles. So it says write the inputs and outputs from part B through D. Well, if we look here, our inputs, remember, are our x values. So I inputted 14, and when I inputted that into the function, I got out 2 miles. When I inputted 28, I got my output of 4. So we're going to take these points here, 14, 2, 28, 4, 7, 1, and we're going to put those on our graph. Now again, x-axis, x is our minutes, and it's helpful if you do label the graph, the coordinate plane, because it kind of tells you what's going on. So this will be miles on this side. Okay, so again, taking the ones we did 14 14 minutes, that's 2 miles. And we did 28 minutes, which was 4 miles. And we did 7 minutes, so I'm going to go right between the 6 and 8 here, up to 1 mile. And what do we notice about the points you plotted? Well, if you kind of look here, kind of looks like this is, they appear to be on a line, right? So from the information we have, that appears to be on a line. Shouldn't be surprising though, right? Because we know from our equation here, our variables are to the first power, so we expect it to be a line. Okay, so if we wanted to, I'm going to draw a line through these points, as always, a nice long line through the points, straight as I can get here. Part G says, use the equation you wrote in Part A to determine how many miles you can run in 36 minutes. Well, our equation, remember, was y equals 1/7 times x. And if we want 36 minutes, that's x equals 36. So I'm going to say y equals 1/7 times 36, which gives us 36/7. That doesn't work out so perfect, but if you approximate it, it comes out to 5 1/7, or you can say it's approximately 5.14. So when we input 36, we expect an output, a y value, of about 5.14. Now, it says include the point on the graph, where it is the point where you expect it to be. Well, I would expect it, and hopefully expect it to be on the line as well. So we're going to say it's going to be on the line, so let's look. 36 is right here, and we go up 1, 2, 3, 4, 5, just past the 5. And I'd say it's exactly where we expected it. So assume they use a rule to describe the function, this whole thing, for however much time, however many miles, this is going to hold true. Where do you think the points are going to appear? So every time you pick a number of minutes and put it into the function, get a number of miles out, where do you think that point is going to appear? And I'm going to say it better appear on the line. And what do you think the graph of all input-output pairs would look like? Right down here, bottom. Okay, we're going to straight line. Why? They explain there? Well, if we look at our formula here, we have a constant. If we look at our formula right here, there's a constant. We're multiplying by a number. So why is it a straight line? Well, there's a constant rate.